Welcome to this presentation of Course 2, Module 6 on Etherchannel. We're going to take a few minutes to go over what Etherchannel is, its uses, limitations, what protocols are used to negotiate a connection, etc. I've also set up a network and packet tracer so that we can go over the process of setting up Etherchannel in a network. So let's get started. Etherchannel is a technology that allows you to group multiple Ethernet links together into a logical link. Because the Ethernet links are grouped together into a logical link, a spanning tree protocol has no need to block the individual loops within an Etherchannel. When an Etherchannel is configured, the resulting interface is called a port channel. In this figure, it shows the physical interfaces bundled together. This little oval symbol is the symbol for an Etherchannel in a network diagram. Etherchannel has some advantages. Increased bandwidth without upgrading the link to a more expensive, faster connection. It provides load balancing, and it also provides redundancy because if one individual Ethernet link goes down, it does not bring the entire Etherchannel down. You'll have reduced bandwidth on that Etherchannel, but the Etherchannel maintains its up status. Etherchannel does have some restrictions. You cannot mix interfaces. You aren't able to combine fast Ethernet and a gigabit Ethernet into one Etherchannel. Etherchannel supports a maximum of 8 Ethernet links, and some devices actually have a lower limitation that you can use. For instance, the Catalyst 2960 switches only support 6 links per Etherchannel. And physical interfaces must be compatible on both ends of the Etherchannel. That means speed, duplex, VLANs, VLAN trunks all have to be compatible and configured the same way on both ends. There are two protocols used for negotiating an Etherchannel. PAGP, or Port Aggregation Protocol, is a Cisco proprietary negotiating protocol, and LACP, or Link Aggregation Control Protocol. Etherchannel can also be configured using unconditional static configuration without either of these protocols, and we'll go over those during our packet tracer configuration. So when setting up Etherchannel using PAGP or LACP, there are two negotiating states you can configure. One is active and one is passive. The interface in the active state is responsible for initiating negotiations with the other interface. A passive negotiating state receives only. You must have at least one interface in an active negotiating state in order to negotiate an Etherchannel connection. So this is the PAGP mode settings example. Go ahead and just ignore the top two lines where it says on. On is not really part of LACP or PAGP. That's how you set up a static Etherchannel connection. The bottom four lines of this table show the negotiating states that will establish an Etherchannel connection. Desirable is how you specify an active PAGP negotiating state, and auto is passive mode. And LACP has the same functionality as PAGP, but is not proprietary. So if you're working in a network that does not have Cisco switches, then you would need to use LACP. And LACP conveniently refers to its active negotiating mode as active and its passive mode as passive. Easy to remember. Again, as long as one interface is active, you will have an Etherchannel established. Alright, so let's take a look at configuring Etherchannel. So here we have 3 redundant switches, and I've put on a couple of VLANs on each of these. And we're going to set up 3 port channels, or 3 Ether channel connections. And we're going to do a PAG-P connection between between switch 0 and switch 2 on the gigabit Ethernet ports. And we're going to set up a second port channel using LACP between switch 0 and switch 1. And last, we're going to do a static configuration on port channel 3 between switch 1 and switch 2. Notice right now that STP is kind of freaking out a little bit. Well, not really freaking out, because STP is just doing what it does. It's blocking loops, and there's a lot of loops in here. If there's not, remember, these are not Ether channels yet. These are just Ethernet links, creating loops. But when we get done, we'll have, these will all be green, except for there'll still be 2 that will be orange, because this will all be this will be one link, this will be another link, and this will be another link. There'll still be a loop that STP will block, but it won't be blocking all of these. It'll just be blocking one set. Let's start with switch 2. Okay, and the first one we're going to start on is port channel 1, which is the PAG-P Ether channel. So let's start with interface, port channel 1, switch port mode trunk, because we have multiple VLANs, so we want all those VLANs to be able to communicate over this. And we will define which VLANs those are. Trunk allowed, and I'm going to include the default VLAN in addition to VLANs 10 and 20, which I set up earlier. Okay, good. And we're going to modify the interfaces for the gigabit connections. And I'm going to do both of them at the same time. So interface range. Okay, first thing we want to do is shut them down. Assign channel group 2. Oh, excuse me, channel group 1. This is channel group 1 we're working on, the PAG-P. Mode, and we're going to make this one the active link, which in PAG-P is desirable. It's going to yell at us because the other end is not configured right now, and they have to be configured in the same way for them to properly work, but we'll get there. Okay, so let's go ahead and close this, and we'll go over to switch 0 and configure the other end. Again, it's interface port channel 1. Oh, probably should go into global, configuration mode first. Switch port mode trunk. Switch port trunk allow VLAN 1, 10, and 20. Now this end, we're going to do this end in passive mode. And in passive mode for PAG-P is auto. And I forgot to do the shutdown, but it'll shut itself down and bring itself back up automatically. But I should have shut that down first. So yeah, let's fast forward our time a little bit. And look at that. Already we have gotten rid of that of spanning trees blocking state on this ether channel. Okay. If I do show ether channel, shows 2 ports using PAG-P. So that looks good so far. So let's proceed on to the second port channel, which we're going to use LACP. Okay, so pardon me, I had a little problem with the recording. So I just configured the passive mode for the LACP port channel 2, passive mode for interfaces 21 through 24. There, and then I brought the interfaces up, fast forward to time, and we're all in the green right here, so that's looking good. And the last one we want to do is the static version. And we'll start with switch 1. And this is interface port channel 3. Set it up the same way as a trunk. And allow the VLANs. And we're working on interfaces 11 and 12 on fast Ethernet. And it's interface range. Okay, let's shut them down. Assign them to channel group 2, channel group 3 mode, and when you're doing static, it is mode on both ends. No shutdown. Last but not least, back to switch 2. And we're almost done with this. I don't find this to be that difficult. I don't think it's of course I say that and I make a mistake. I don't think it's worth getting an aneurysm over like some people say. Certainly not as much of a pain in the butt as IPv6 is, just in general. So faster Ethernet ports 11 and 12, I believe, right? Yep. I'll shut them down. Assign them to channel group 3. Mode on. And no shutdown to bring them back up. Looking good. And now we have 3 working ether channels. STP is just blocking two logical links like you'd expect it to do. And this is a 400 megabit connection between switch 0 and 1, a 2 gigabit logical connection, ether channel connection between 0 and 2, and well, switch 1 and 2 only has a little 200 megabit ether channel connection. Alright, so let me pull this back here. And there are some commands that you will need to know for doing troubleshooting. The show interfaces, port channel, show ether channel summary. You want to know those. But this is all Etherchannel is, so that concludes this presentation. If you have any questions, feel free to contact me, and you have a great day.